Hey, I'm Anthony from KodeKloud. Today I'll explain the core concepts of the Sidecar Proxy within Istio and how it enhances observability and security. Let's jump right in, and remember to subscribe and like the video at the end if you find it helpful.
We already talked about the job of a sidecar, but to quickly summarize, Envoy proxies ensure established secure connection between workloads. We also talked about automatic sidecar injection, and that happens when you label a namespace with the Istio injection enabled, and when you don't, that namespace doesn't get that Envoy proxy, as you can see here with the payment namespace. It wasn't Istio injection enabled, therefore it doesn't have an Envoy proxy on your workload, like you see in this diagram, right? Traffic can still flow if there are no peer authentication policies. We'll talk about those later, but the namespace here without the Envoy proxy don't benefit from the sidecar's features like secured mTLS, monitoring, reliability, and other advanced options we talked about like mirroring, fault tolerance, etc. This is why it's necessary to enable Istio in the namespaces you plan on running workloads. When a namespace is enabled, like the Istio automatic sidecar injection, Istio applies a default sidecar behavior that is quite permissive and will allow basic mesh features to work. This permissive mode basically allows traffic to go in and out to any other workload, regardless whether that workload has Envoy proxy or not. So it allows mTLS communication as well as plain text communication. Now, the default behavior of a sidecar is that all traffic in and out is intercepted and managed by the Envoy proxy. By default, the sidecar will outgoing traffic, including traffic to services in other namespaces and or external services, right? Now, mTLS is not enforced, like I said. By default, it's not enforced unless you globally configure it. But if you do enable it, the sidecar will enforce mTLS for communication between services that are part of the mesh. Finally, default behavior of the sidecar proxy will handle basic traffic management features like load balancing, timeouts, retries, logging, circuit breaking, rate limiting, etc. You can go with the default behavior, and more often than not, that's sufficient, but you might want more fine-grained control over the sidecar's behavior, for specific namespaces. For example, you can specify that the payments namespace can only communicate with the app namespace and the Istio system namespace, but deny everything else. You can enforce, this type of, policy if you really want to control what traffic goes in and out. Like I said, the default behavior is usually sufficient, but if you did want that control, you can add that in the sidecar configuration. Now, in order to apply, or override the sidecar configuration, you need to create a YAML file, as of course you already know, and apply it to override that default behavior I was talking about. In this example, the sidecar is applied on the payments namespace, right? It will only override the sidecar default behavior on the payments namespace. And here you can see the egress or outbound traffic for payments namespace only permits traffic to the app namespace, right? You can see that app/*. The Istio system namespace, istio-system/*, and all workloads within itself. That is defined by the /* that you see there. That means itself. Now, the /* is a wildcard for all the workloads in that namespace. For example, app/* means all of the workloads in that namespace. And this is how you would override the default behavior, right? So now all the workloads in the namespace payments could only talk to these three namespaces, or two namespaces here, the app namespace and the Istio system namespace and itself. Anything else, the sidecar will not allow to go out. And you can apply it, of course, on top when you set up your file. Now we will review all about security in the securing workload section. However, it should be noted that mTLS is not enforced out of the box, like I said, unless you configure it. And by default, the mode is set to permissive. And the permissive mode allows mTLS and plain text communication, meaning that all namespaces will allow traffic to flow whether you have an Envoy proxy injected or not. Now, this peer authentication right here we are applying is on the app namespace, and it's set to strict, meaning that any other workload that wants to talk to the app namespace will need to have Istio injection enabled so that mTLS, so that you can communicate with it, because now it's setting it to strict. Like I said, the default behavior is set to permissive. So this is adding very strict policy saying I'm only allowing or I'm only accepting mTLS traffic. And on the right side here, you see the sidecar configuration for the payments namespace. And in this case, like I said, this payments namespace will only be able to communicate with the app namespace, right? As you can see right there, and the Istio system namespace and nothing else. It is important to note that both namespaces here, the payments and the app namespace, would need to be Istio injection enabled. And that's how you take advantage of Istio's features. If the namespace is not Istio injection enabled, benefit, or you could create these resources, but they will do nothing because you need the Envoy proxy in order to, take advantage of these features. This is just a sidecar example configuration you can see here. It looks a bit confusing. This example here declares that a sidecar configuration in the book info namespace for all the pods with labels app ratings, right, will accept incoming HTTP traffic on port 9080 and then forward it to the attached workload instance listening on a Unix domain socket. This workload sends only outgoing HTTP traffic on port 9080 for all the workloads in the book info namespace and outgoing traffic to any workload in the Istio system namespace. In the exam, there might be a question like that. We'll talk about it more in the demo. And finally, there are many options that you can add for the sidecar configuration, and you can check it out by going to Istio's documentation under reference, configuration, then traffic management, and going to the sidecar. You can find all the options for the sidecar there. This is really important. You must know how to get here. You should go through this, and when the exam comes, you should know how to find this and be able to add your sidecar configuration. There is bound to be at least one question around this. I don't think it's going to be too hard, but it's worth having a look at this documentation and knowing where certain things are. All right, and welcome to the first slab of the traffic management section, which is the largest section by far. So sidecars. I know it might be a little bit confusing, but don't worry, we'll get through this together. So the first thing I want to do here is make sure that our default namespace is Istio enabled. So I'm going to do kubectl get ns show labels. And sure enough, our default namespace is enabled. So we can essentially carry on. We have that sample book info application. So I'm just going to copy the command right here and I'm going to apply that. I'm going to go ahead and clear this. Let's do kubectl get pods. And initializing, you can see right here that we have 0.2 for now. But essentially what this means is that Istio is injecting the sidecar proxy. So we know that everything is going to be proxied through that sidecar proxy. I'm just going to give it a second right here. And while that's initializing, I don't think you'll have any issues. I'm going to go ahead and close this. And we are going to create a new namespace. So we'll do kubectl create ns namespace called test, let's say. And if we do kubectl get ns show labels again, you'll see that this test one is not Istio enabled. So essentially what should happen is that any pod that I run inside this test namespace should not have the sidecar injected. Let me do the get pods again. kubectl get pods just to make sure they're up and running. Yeah, everything is running right here. So I'm gonna go ahead and clear this out of the way. And now I want to run a pod in that new namespace that we created, that test one. So kubectl run, we'll call this test. We'll use the nginx image and we're going to do on the new test. Yeah. So if I do kubectl get pods and test, you'll see that we have 0 of 1, which makes sense, right? Because Istio is not enabled on this namespace. So let's see if that comes up. Yep. Now it is running. So next thing I want to do is see if I can hit that book info application from this test pods. So the first thing I want to do is get the services for the default namespace. And sure enough, there's the product page. This is what I need. And now I want to SSH into this test pod that you see right here. So we're going to do kubectl exec -ti test. We'll do bin bash, right? And now we're going to use the curl command. We'll do head so that we can just get the response and not like the whole actual content of this product information page. So I'm going to do product page.default svc cluster.local, and that runs on port 9080. So 9080. And you can see here that we get the 200 response with a bunch of headers. Now that obviously it works. And the reason that it works is because the default behavior right now is that all traffic comes in and out inside the service mesh. There isn't anything restricting that from happening. So if you install Istio out of the box, because they don't want to start blocking traffic, essentially when you install Istio, all traffic is flowing in and out of the service mesh without you having to add any policies. And then the idea is that you add on what you need and what you don't. So I'm going to go ahead and exit this. Let's clear this out of the way. And now what we want to do is we want to add this peer authentication. Now we're going to talk about this more in the security section, but for now, just bear with me. We're going to create a file here called peerauth.yaml. And I'm just going to copy and paste my content here. Hopefully it's going to... So we're going to create this resource called peer authentication, and we are going to put it on the default namespace. Now, what we are telling right here, Istio, is that for this namespace, for the default namespace, we want to enforce mTLS traffic. So I'm going to go ahead and save this, and I'm going to apply it. Apply-f peer auth. And now what we can do is we can retry the exec command again. So I'm going to SSH into that test pod, and I'm going to do curl again with the head. And what you'll see here is that you're going to get a fail, or it's going to fail. You're going to get this connection reset by peer. And the reason that this doesn't work because of this peer authentication policy, because this is telling the namespace that it will only accept mTLS encrypted traffic. And that can only be done through a sidecar proxy. Now we already know, show labels, that the default namespace is Istio injected, but the test namespace isn't Istio injected. So there is no sidecar proxy that can encrypt that traffic and send it to the book info application. So I hope everybody understands that part. So now let's fix this. So I'm going to clear this out of the way. And now what we want to do is we want to label the namespace. So the test one. So kubectl label, and we're going to do namespace test, and we're going to do Istio injection equals enabled. And now let's show load labels. And sure enough, now we have the Istio enabled for the test namespace and also for the default. What I can do right here is I can delete that pod and the test namespace. So kubectl delete pod and test that. Get pods. And nothing is here. Now let's run that pod again in the test environment again. The same image, everything. Now let's get pods. And then now we have one of two. It's doing the sidecar injection. I'm going to clear the screen. Let's do exec again, right? And now we are going to curl head. I think it's product page.default.svc.cluster.local 9080. And now it works, right? It works now because traffic is being encrypted through the sidecar. It's going through mTLS, and the sidecar proxies are handling that traffic. I should also mention that you don't really need the whole path. So you can just do product page. I know that a lot of people are probably going to say you don't need to do the whole thing. Oh, you do need to do it. Okay, never mind. Default SVC. Yeah, you just don't need that cluster.local, but I digress. So I'm going to go ahead and exit this. I'm going to clear the screen, right? So we understood what happened right there, right? We had our application, well, one namespace, Istio enabled, the other one isn't. The one that isn't was able to communicate through the book info app without any issues. But once we put this peer auth, then it didn't work until we enabled Istio injection on that test namespace, and then it worked. So what do we want to do next is that we want to create a sidecar resource. So we're going to do vim sidecar, and we're going to call this default namespace YAML. And I am going to copy something from here. So this should look very similar to what we had in our presentation or PowerPoint presentation slides. So we are going to create a sidecar in the test namespace, and the name can be default. In fact, leave it as default. And we are going to pass in the egress. We're going to allow outbound traffic for the Istio system namespace. Everything in the Istio system namespace that's represented by the asterisk here, or wildcard, whatever you want to call it. And then this one right here just says itself. So this ./wildcard means any outgoing traffic to itself. So if there's another, another pod with another service in this test namespace, it will be able to handle that traffic. So I'm going to go ahead and save this. I'm going to do kubectl apply f sidecar, right? And I think it's important to note right here, what we're doing here is we are overriding the default behavior that Istio is already doing. Because if you recall, before I created this sidecar, traffic was going in and out without any issues. That is the default behavior of the Istio sidecar. When we create this resource sidecar in this namespace, we are telling Istio, hey, wait a minute, I'm going to override a few things right here. And what we're overriding here is we're saying, hey, in the test namespace, only allow traffic to these two namespaces. So let's try to do the exec again. So we're going to SSH into that test pod, and let's try to do a curl. And you'll see that now we don't get that connection reset, but now we get an empty reply from the server. So this is not able to communicate because the sidecar only allows traffic to both of these namespaces. So let me go ahead and exit that. And let's fix this. So I'm going to do the sidecar again. And here I am going to say default, right? Because we want the test namespace or workloads in the test namespace to communicate with any workloads in the default namespace. I'm going to say, save this. I'm going to apply sidecar default namespace. I'm going to clear this. Let's do the exec again. And let's do curl. And now it works. I added the default namespace. So this is just a sidecar is a way for you to restrict certain things. Now we could try another thing. Let's open up that sidecar again right here. And now instead of just doing the whole namespace, I want to restrict certain workloads from being able to get out. So what we could do here is under the spec here, we can do workload selector. And under the workload selector, we can do labels, right? And we're going to do the run tests. Like that's the label of the pod. So if we do kubectl get pods in the test namespace and we do show labels, you'll see that this has the run test. This is the default label. When you run any pod, you'll get the run equals whatever the name of the pod is. In this case is run test, right? So let me go ahead and apply this. So apply the sidecar namespace, right? Oh wait, one thing that I wanted to do is actually remove this namespace right here. I'm going to add a sidecar now, and I'm going to strictly, I guess for all these pods that have the run test, which in our case is just going to be one pod, I'm going to restrict it from going out to any other namespace that is not itself an Istio system. So now we're targeting specific workload selectors, right? It's no longer the whole namespace. Now it's just these workloads. So I'm going to go ahead and apply that. And let's try the exec again. Now, what do you think is going to happen? Is it going to work or not? If you said it wasn't going to work, you'd be 100% correct. And the reason that this doesn't work is because we are targeting specific work labels and we're saying, hey, those workloads in that namespace, so in the test namespace, for these workloads that have this label, can only go out to themselves, to the test namespace, and to Istio system. So now let's try one last thing right here. Let's do kubectl run, and we're going to call this nginx. So it's not going to be test. We're going to use the same image, nginx, and we're going to put it in the test namespace. I'm gonna clear that. So let's check kubectl get pods in the test, and I want to do show labels. And you can see that here that we have the Nginx pod, which is the same image, but now instead of doing the run test, this one's called run Nginx, right? So now let's exec into the Nginx pod, not the test pod, although in the same namespace. And let's try to curl that. So let's do curl head product page default svc 9080. What do you think is going to happen? Is it going to work or is it not? If you said it was going to work, you would be 100% correct. And if we do exec, and we're going to do the test here, and we're going to do curl, you'll see that it's not. So again, the sidecar is deciding this because we are targeting specific workloads in a specific namespace, and we're saying that these specific workload can only go out to these two namespaces, while the other pod that is just labeled run Nginx doesn't fall into this sidecar workload selector, which is why the Nginx pod is able to get out with any issues, but we restricted the traffic going out for the run test. Now, would you ever need to do this? Maybe. It depends how much you want to control the traffic. For the most part, the default behavior for the sidecars is sufficient. You can restrict certain things, and we're going to learn all about that in the security section. But this is definitely going to be in the exam, at least one question. And I want to just point you again to the documentation. I'm going to reiterate, and I'm going to sound like a broken record, but you definitely need to know how to get here. So remember that we're going to talk about this in the common issues or the tips, whatever, at the end of this course, but you definitely need to know how to get here, because when a question arises about a sidecar, you want to be able to get to this documentation and then be able to copy it and then apply it, right? So you'd be able to go sidecar.yaml and you want to paste that on. You don't want to be spending time typing this, right? You want to be able to copy it and paste it immediately. So please have a look at this. A question is bound to be exactly like this. It could be even a question to send default add endpoints. There's a lot of things here that you can do with Sidecar. We obviously don't have time to cover it all, but make sure that you're aware at the very minimum how to get here. And when you read the question, you can do a Control F and look for, for example, I'm going to look for this Unix, this socket endpoint, so that you can have an idea of how they did it in there. So really important. And that sums it up for sidecars.
If you're interested in mastering Istio and leveling up your cloud native skills, check out our comprehensive Istio Certified Associate course on KodeKloud. We offer hands-on labs, real-world examples, and everything you need to pass the ICA exam. Click the link below and get started today.